became involved in outreach. Let's see, was there?
It's not even civil life science.
The old eyes aren't what they were earlier either. I became involved in activities with college teachers and students about 25 years ago. But it really wasn't until a little bit later that I started becoming involved in earnest. And it started out with a teacher outreach activity that we call chemistry enrichment for middle school science teachers. And Vinay Kumar, who's here and there, there's Vinay back in the corner. He and I decided that we would apply for a grant to have a summer workshop for middle grade teachers. At that time, there was a move afoot to try to bring more science into middle grade activities. And we found out that the grant was due in 2 weeks. Well, I thought there's absolutely no way that we can do that. But Vinay talked me into it. We submitted, and much to my astonishment, it got funded. We made one really, really wise decision. In this chemistry enrichment workshop, we recruited 2 middle grade teachers. Let's see if I can point them out. Cindy Trudeau and Gail Osmond. They kept us on the straight and narrow. Anytime we got too far afield with theory or whatnot, they would bring us back. And then that kind of set the mode. Any workshop, any activity I did from then on, I tried to bring in the people that were going to be affected by it. There's nothing better than teachers teaching teachers. Now, in this particular workshop, it was a model that we used fairly often later on. We had a morning lecture and demonstrations, and then we had an afternoon lab. Now, back in those days, you can see this fairly long ago, we didn't even have color photography. Back in those days, middle grade science budgets were very limited. So one of the wisest things that we did is we tried to give them a kit of materials so they could produce many of the activities that we showed them. So although in this particular picture, and this is me over here, somewhat before the chin, got a little fuzzier, spectroscope. But what we knew that there's no way that they could afford a spectroscope in their classes. And I had noticed something that were called fireworks glasses. And these fireworks glasses have diffraction gratings built into them. And they're fairly nice diffraction gratings. They're around, 5,000 lines per centimeter. So what we did is we used these for some of the activities. So again, since y'all are pretending to be some of the students, if I can have some help, we'll take a look. If it's a continuous spectrum, you can see all the colors of the rainbow, or a discontinuous spectrum where you can only see a few colors. We'll start out with an incandescent light. Okay, you should be able to see all the colors of the rainbow. This is an example of a continuous spectrum. If you take solids and liquids and you heat them until they give off light, at least in the visible range, they tend to produce a continuous spectrum. Okay, next we'll take a look. That's something that's a little bit different.
This is awesome.
You should see something different. You should see different images of the cone, and then you'll see dark areas in between. This is an example of a band spectrum, where you have gases, at least molecular gases, under moderate to low pressures, you get band spectrum. They're centered around electronic transitions, but you can also have vibrational and rotational transitions that broaden the spectrum. So then what you see are individual bands. Okay, next we're going to take a look at the spectrum produced by an element. We have here some discharge tubes, and these contain mostly rare gases where you just have individual elements. Okay, so we'll take a look at these. In this case, because they're individual atoms, we can't have vibrations or rotations. All that can happen, we can excite electrons to high energy levels, and then when they drop back down to low energy levels, they give off light. This one is the spectrum of helium. Oh, sorry, I got the wrong one. We'll get back to that one later. My age is which end of the table to start from. This one is helium.
Oh, yeah.
And this was actually discovered on the sun in 1868 by Lockyer, before it was discovered on the surface of the earth. He was very proud of that, so proud that Maxwell actually wrote a ditty about that. And Lockyer gets cockier and cockier because he thinks he's the owner of the solar corona. It wasn't until 30 years later that it was discovered by Ramsay on the surface of the earth. Okay, now if I have a different element, remember now you're sixth graders, do you think you will see the same spectrum? No. Do you think you'll see a different spectrum? Okay, we'll try that. This time we'll try neon. Wow. That's used in the neon light. We have a different atom, we have a different pattern of energy levels, so we get a different spectrum. Now some of you may have been in parking lots at night where your lips appear blue. Cars you distinctly remember as being red have a bluish cast. That's because they are often lit with mercury lamps. And this, which I accidentally showed earlier, you should be able to see a yellow, a green, but you should also be able to see a couple of lines in the blue and the violet range. There's also red. At my age, I have a little hard time seeing the red. There's a red line there as well. The key idea here is no two elements have the same emission spectrum. So we can use that to identify those. We can identify them by the pattern of light. Okay, now then we'll take a look at the second major type of light that we have in the home. And that's a fluorescent light. You ready for this? Oh. Okay, you said continuous spectrum or discontinuous spectrum? You should see all the colors of rainbow. There's a little difference here. In the case of an incandescent bulb, although you can get some that are frosted, you get many of them that are clear. You will never find a fluorescent lamp that has a clear cover. And actually a fluorescent lamp is basically just a discharge tube like this. But this white that you see is a phosphor. And that phosphor absorbs the light given off by the element inside. And then it in turn gives off all the colors of the rainbow. Now, what we'll do is we'll see if we can identify that element. And what I'm going to do is I'm going to put a screen in front. Okay, now then when you look at it, you should be able to see about 3 lines that are a little brighter than the others. There should be a yellow, a green, and a blue. Some of you probably can see some others as well. My age, that's about all I can manage. And if we compare that with what we have here, then we can tell that the element inside a fluorescent lamp is mercury. A full-scale fluorescent lamp has about 20 milligrams of mercury in it. So we know mercury is toxic. So you have to be careful when you dispose of those. I think many of you know that when Lewis Carroll wrote Alice in Wonderland, some of the traits of the Mad Hatter were actually based on hatters that lived at that time. Because frequently in treating the felt of the hatter, they did a process that was called keratin. And in keratin, they used mercury compounds. They would heat them in big vats so they would get some mercury in the atmosphere. So they tended to have some brain damage due to mercury poisoning. That wasn't found out.